Okay, so page 12, right? Okay, so I went through A through G, so I can go down the second column.
Okay.
Okay, so some of it is kind of just playing around with the forms, and if we don't like the form that we see in front of us, we can always convert it into a different form and see where that leads us. So here, I have log base x of this value equaling 1/2. So I'm going to get it into exponential form. So I'll start with the x raised to the 1/2 is equal to 64 to the 1/3. Are you good with that conversion? Okay. So we want to maybe solve for x, but maybe this side can clean up a bit because 64 to the 1/3, that's same thing as cube root of 64. So basically looking for three numbers that multiplies by 64, that does end up being a nice number, ends up being 4, right? Because 4 times 4 times 4 is 64.
Oh, okay.
So now we're getting to a point where it's a little bit easier. I want to get rid of that 1/2. So if I square both sides, basically that's square root right there. So if I square both sides.
And then if it's negative, it means to flip it, right?
That's right. If it's negative, that means you're going to flip that x to the denominator. But yeah, 1/2 times 2 is 1. 4 squared is 16. So x is 16. Okay, part D, natural log of x equals natural log of 8. So this is similar to, I think, a problem like part E, where if I can get the two sides to match exactly, showing natural log, hey, then I can, we're on page 12 right now. If I can get both sides to show natural log, then I can remove them and see what's left. But it's not quite in that form yet. That 1/3 is kind of getting in the way. So what if I can move that natural log? Oh, sorry, 1/3. So that 1/3, maybe I can push that up as an exponent just for placement purposes. So if I bring that 1/3 back up, we said that within a natural log, that coefficient is free to move. And here,
Oh, so you can do that, like move the.
yep. So we have this property where if I have natural log of a to the n, that exponent can either come down or stay up, depends on whichever form is more helpful for your problem. So now that we have natural log of x to the 1/3 equals natural log of 8, now that we have that 1-to-1 natural log relationship, we can remove the natural logs. And then we're left with the easier equation to solve here. So x to the 1/3 equals 8. Basically, that's cube root of x. So I want to undo that cube root, so I can raise both sides. Exponent of 3, 1/3 times 3 is 1. And then 8 to the 3rd power 2. 512. Okay. All right, part F, 4 natural log of x plus 3. In this one, if I can get that natural log by itself, maybe I can work with it a little better. But here, anytime that I can see some ways where things can combine before I get into the natural log and conversion, I see the 4 and 12 should be able to combine, right? So I can just divide both sides by 4, get that out of the way. So I want to solve for x. X is stuck inside that natural log form. So we can maybe think about what would this look like in exponential form. Maybe that will clear things up a bit for us. So we know natural log is log base e. Let me rewrite this equation so I can see that base in front of me. Okay, so now if I get this into exponential form, base e raised to the third power equals x plus 3. So we really don't care about if our decimal value, if I can just get x by itself, that's all we need to do. So if I can subtract the 3 over to the other side. Okay, do we do h together?
Yeah.
We did, okay. Yeah, any questions there? Or any questions with the other ones, A through H?
Not really. I think it was just kind of like wish money.
Okay. Yeah. Okay.
Oh, sorry, you have a question?
Oh, I was gonna ask, like, what's the different approach you do for page 17, like when it's like parallel versus when it's perpendicular? What's the difference in like how you approach the problem?
The difference is that if you're looking for parallel, then you're just going to pick out the slope. So let me do a So let's say I have an equation that is in the form of y equals mx plus b. The slope of that line is basically what that m value is. So if I want something that is parallel to that line, then I'm just going to copy whatever slope that they have in that equation. So my parallel is just whatever that slope value is. But if I want something perpendicular, I got to take the negative negative reciprocal. So let me give you an example here. So if I have y equals 3x plus 4, that line has a slope of 3. So if I want something that's parallel to that line, then I'm going to use slope 3. But if I want to use a line that has a slope that is perpendicular to 3, then I have to flip that number and change the sign. So I got to make it negative 1/3.
So, well, like M1 always be the parallel one and M2 always be.
Yeah, so in my key, I had M1 being the parallel slope and M2 being the perpendicular slope.
I know you slope intercept form there, but didn't you say you were usually going to use general form?
We do point slope form, but if you want to use slope intercept, that's fine. It's just that you know, down the line when we get into our calculus where we're asking for tangent line equation, we're going to jump to point slope form because it's just faster. It's not wrong to do slope intercept form, but you're just adding an additional step to get to it.
Okay.
Yeah. Okay. Any other questions, problems you want me to go over with you?
Over the summer,
Mhm.
for the unit circle, the
Mhm.
way I did it was I actually like read out the equation, like a 45, 45, 90.
Okay.
So do you think it'd be best to like start trying to memorize all of them? Because I feel like it's faster that way. I feel like
Yeah, you kind of do because you don't want to, when we get to a calculus question, that's gonna be the last step, trying to get the ratio of a trig. We don't want to spend, you're not gonna have 10 minutes on top of your test to do a unit circle, from beginning. So yeah, I would look to memorize, and I think that strategy of using that first quadrant to help you around the unit circle, I think that's the best thing. But if you have any specific questions, I can kind of help you nail that down a bit more.
yeah, I understand it.
Mhm.
It's just that it takes me a while to actually like figure out what it is.
Yeah, for sure. But do you see that, that if you have these 3 memorized, you should be able to make your way around the other unit circle values without having to write everything out?
Yeah, you can just like flip it, right? Or
Yeah, more or less. depending, yeah, I mean, I guess it takes a little more work if it's like secant, cosecant, cotangent. But in terms of sine, cosine, and tangent, we should just be able to rely on the numbers that we find here. Are you do you have trouble with these three
Oh,
measures?
no, I think the radians are pretty easy.
Okay,
Like,
okay,
I memorized those values pretty easily.
okay.
I just think finding the cosine and sine values and like memorizing them, I didn't do that. I
Okay.
did it a different way. 'Cause,
So does this make sense? These order pairs that
yeah,
we create, right? So, I mean, this only takes a second, so I think having this down on your paper is not too bad. Right, and then just know that every x value that you see is your cosine, every y value that you see is your sine. And if I do y over x, that's gonna give me my tangents.
okay, so tangent just, oh wait, no.
Yeah, tangent is just sine over cosine. So if I want to find the tangent of pi over 6, I can just do 1 divided by √3. I can just ignore the 2's. The 2's will cancel each other out, so just do 1 divided by √3. That's the tangent of pi over 6.
All right, well, I guess that was mainly it.
Mhm.
I'll try and memorize it over the weekend, I guess.
Okay.
'Cause
Yeah, I mean, we're not gonna have a test on this unit per se, but I really want students to, feel comfortable with everything in this packet. So when we get to the calculus, we're not having to kind of, review a whole lot. Yeah.
So like, I was just trying to look for really what I was really confused about, and there's like one certain thing. The top half of page 18 where you have to like substitute functions. I got really like confused on that.
Mhm.
I don't know, it just really got to me. I just didn't really understand it. Can we go over those three problems, like A, B, and C on?
Yeah, sure. Okay, so page 18. So we want to be able to get this function to take on this form. So this is what my goal is. Okay, so here's my function, right? My function is f of x equals 3x plus 7. So if I want to make a substitution, this piece is ready to go, right? I can replace f of x with 3x plus 7, and there's no work that's required, right? That's easy to do. The thing that students have a little more trouble with is how to build this f of x plus h. Okay, so the way that I think is easiest is let's go ahead and see if we can create a space where that x plus h is going to go. Okay, so rewrite your equation with the x removed and saving a reserved space for a new argument.
Okay, so like you substitute the X plus H into where the X previously was.
That's right. That's right. So now that you have this, if you can do this, you will not make a mistake with x plus h because there's only one place for your x plus h to go, right? You have already reserved the space for it. So now you can put the x plus h inside your parentheses, and that's the only place it goes. All right, good so far? All right, so now what's my substitution that I can replace with f of x plus h?
3x plus H
Plus 7.
plus 7.
Yeah, so now I'm going to take this right side and replace it with this, replace it for this expression. We're basically just getting these numerator out of function notation, which we're going to see, right now it doesn't mean anything to you, this form, but when we get to our second unit, this is going to move towards the limits and derivatives, and it's going to be something that we're going to need to use. Okay, so we go with this substitution here, this part here.
Yes, that's the part I was probably most confused on. It's a starting over.
And then minus what?
3x plus 7. It's just,
Yeah. But careful, what do we have to be aware of?
minus 7.
Yeah, so, well, I would say 3x plus 7, but just leave a set of parentheses after the minus sign because this negative is going to end up changing the sign of both your terms. Yeah. So now I can just combine like terms and see how much I can clean up. And that's as far as. So right now it just feels like an algebraic problem. There's meaning behind this expression, but we'll get to that in unit 2. The 3x's cancel out, the 7's cancel out. I'm left with 3h over 3h over h, which is reduces even further. The h's cancel out. I'm left with 3. Now, it's not always going to cancel out this cleanly. You're just, for all these problems, you're just trying to get it as cleaned up as you can. And once you can't go any further, you stop. Okay, you want to go over the other two? Sure. Okay, build your f of x plus h. That's the hard part. The hard part is just building your f of x plus h. After that, you're just replacing your numerators with the given and the new function, and then cleaning up after that. So my example, actually, I did not clean up that far. I just put it in the numerator form, and then I just left it alone. I guess we could have expanded even further, distributed this out, combine like terms, but if we can get it to this form, that's a good start.
Oh yeah, this is the one I was. He's like, I didn't know what the answer was, so I kind of solved it on my own.
Okay.
For my, what did I get from?
Yeah.
I think I did expand it like after.
You did expand it. Okay, all right, let's see what we get.
You got 3h squared plus 2h divided by h. I don't know, it's supposed to there. What would be 3h squared plus 2? Okay, I was a little bit off.
Okay. Wait. I think I may have missed something here. Oh, sorry. There's a minus 2h here that needs to remain by. Let me try again. So. Yeah, so 6xh plus 3h squared minus 2h. Try again.
Okay. I struggle when like figuring out when to factor out something. I don't know why. I just think I have a hard time kind of seeing it for some reason.
Yeah, I mean, you basically look at your individual terms and look to see what is shared between all three terms. If there's nothing shared, then there's no GCF, but there is something shared, then that means there is a common factor. So it looks like they all share an H, so I can take an H from each of them. Part C. F of x equals 6 over x. Reserve a space for my x plus h. Okay, so I have a substitution for f of x plus h. I got a substitute for f of x, and then I'm just going to clean it up. Okay, so the way we clean this up is we want to merge these fractions together. So we're going to do common denominators. Okay, so we're just going to focus our attention on this piece right here.
How do you get the additional x? Like, how do you get like 6x plus h? And then you get the number 6 for x.
I'll say it again.
How do you get the two different two different fractions on the top?
Right, so what is f of x plus h?
Well, I'll just make it 6 divided by x plus h.
Okay, that goes here.
But like I'm
Minus f of x, what's f of x?
6 over x.
6 over x, yeah. So I'm just replacing the numerators with my original function and my f of x plus h. Okay, so we do want to combine these together, but in order to combine together, we have common denominator. What's our common denominator between these fractions?
Can be x plus h.
Well, these are different, right?
Yeah.
So that means I need both of them to create my common denominator. So I need x and x plus h. So between the old denominator and new denominator, what's different?
They're both combined now, so you can like.
Well, I need to balance each of the numerators. So what's different between this old denominator and this new denominator? Or what's changed between
There's an additional x.
x? So I need to balance the numerator with an x as well. Let me multiply the top by x. So the balanced numerator is now 6x. And then what's changed between this old denominator and this new denominator?
Oh, the h.
A little bit
Oh,
more,
the h and the x.
the x plus h.
Yeah.
Yeah, so this already has the x, but it's missing the x plus h. So I need to balance the numerator with another x plus h. Now, it looks messier, but now the advantage is we can actually merge these into the same fraction. We couldn't do that before because they didn't have common denominators, but now that they have common denominators, we can actually just combine like terms in the numerator and push it all into one fraction. So I'm distributing the negative through, putting it all into one fraction. So I'm just playing with this upper portion here and trying to get it down to one fraction because now it's a little bit better because before we had two fractions up top, now we're just down to one fraction. there's still a complex fraction here, but once we clean this up, that h can come up in a way where we can reduce. Okay, combine like terms here, 6x minus 6x. So dividing by h is same thing as multiplying by its reciprocal, right? So that allows me to flip that h and come up to the top.
Wouldn't it be H over 1? Simple targets.
Well, the reciprocal of h is 1 over h, right?
Oh,
Yeah, so imagine that h is just by itself. If you want to flip it, it becomes 1 over h. So that means my reciprocal of h will be 1 over h. Yeah, we're not going to think about the fact that it's already in the denominator. We just want to take that h by itself, flip it, and that's what's going to come up. So now you see the h's are directly above each other. That allows me to cancel them out. And then the only thing left over is negative 6 over x times x plus h.
you can't simplify it anymore.
Yeah, can't simplify anymore. Yeah.
Thank you. I just gotta work on the thought process of like multiplying like above the numerator as well as the denominators.
Yeah, it just takes some practice. Yeah.
Getting caught up again.
Yeah, I'm actually getting ahead.
Oh, nice.
Right now, I'm trying to. Which I'm thinking that might be a bad idea because I don't know what I was doing here. Yes, so this year, there's like a 50-50 shot I'm in your class today,
Right,
Like,
because of
performance, but like we don't know if it's gonna cancel because of the Weber.
right. Okay.
I'll see.
All right, I'll see
You
you.
may see me, you may not, so.
Sounds
I don't
good.
have a good weekend. Thank you.
All right, see you, Connor.
Thank you, Mr. Chairman.
All right, see you, man.
I don't think about all this year. How are you doing?
Okay, anything else? Are you good?
Yeah.
Yeah, we'll spend class kind of highlighting problems from the other pages that we haven't gone through, and yeah, just finish the packet over the weekend.
I need to memorize your circle.
Yeah, that'll be good. I mean, the good news is that we won't hit trig until later this semester, like November, December. But you know, the more work you do now, the easier it'll be down the road.
Do I need to like know the graphs too for like cosine and secant? Because
Not too much, not too much. I think the more important thing is being able to quickly know your trig ratios. Yeah. Mhm.
like I'm kind of using your website over that summer too, by the way.
Oh, you did?
'Cause,
Okay.
Like I feel like the way they taught it on Fulton Virtual wasn't I don't know.
Yeah,
It wasn't like organized enough. I don't think.
yeah, I know that sometimes for the virtual, they're trying to just push something out there just for
Yeah.
students to take. And it doesn't end up being quite the student experience that you know,
But my
that's
teacher
good.
wasn't responding to me either. So
Oh, really?
I had to give Miss Connie for help.
Okay.
Uh,
I know. She she was telling me some of the challenges of teaching online, but I'm glad you were able to get help from
Yeah.
her. Yeah.
I think that's mainly it. I think I can get it done over a weekend maybe,
Okay.
but I guess I'll be back here if I need more help.
Yeah, sure.
Thank you.
See you in a little bit.